Welcome to geography session. Now, here we have two terms. One is weather, other one is climate. When it comes to the difference between the both, weather is a short-term phenomenon, whereas climate is a long-term phenomenon. For example, we can say that today's weather is quite hot or quite cold, but you're not supposed to use, technically you're not supposed to use the term climate. Today's climate is hot or cold, okay? Average of weather conditions over a period of time in a particular place is used in order to determine the type of climate prevailing there. For example, India experiences tropical climate, okay? So we are able to conclude about Indian climatic conditions based on the weather conditions that are experienced by India in most of the days of an year, okay? So that is the difference between weather and climate, right? Now, next, when it comes to Indian physiography, already we have discussed, India is known for diversified physiographic divisions. For example, when it comes to the northern part, you have the high-raised Himalayan mountain system. Northwestern part, that is nothing but Rajasthan region, you have the dry conditions completely. You have the Great Indian Desert or Thar Desert being located in the northwestern part of India. And when it comes to peninsular plateau region, you have the plateaus. Here and there you have the hills like Western Ghats and Eastern Ghats. Next you have northeastern part of India, which is known for completely rugged terrain or hilly topography. Okay. So because of that, whenever you take some kind of month or season, you're not supposed to expect uniformity in terms of weather conditions across the country. Okay. For example, you have Cherrapunji and Monsoon, both are from Meghalaya only. Monsoon, in the previous session I was talking about this, it experiences the highest rainfall in the world. Monsoon of Meghalaya experiences highest rainfall in the world. That is why it is considered as the wettest place in the world. Now, when it comes to Rajasthan, especially Jaisalmer, it experiences approximately 9 centimeters of rainfall. When it comes to Monsoon region, it is more than 1000 centimeters of rainfall. Okay. You have another region called Jura from Garo Hills region of Meghalaya. It receives the rainfall in a single day, which is more or less equal to 10 years of rainfall in Jaisalmer. Okay, so two different and quite extreme conditions. Okay, this is all because of topographic conditions. Okay, and relief structures. Now, the factors that determine the climate of India, they are broadly categorized into two types. First one, factors related to location and relief structure. Relief is nothing but mountain, or it is based on the elevation from the mean sea level. And the factors related to air pressure and weather winds. These are the two factors. Now first we'll start with the factors related to location and relief. First of all, you have latitude. We have already discussed that from the equator towards the poles, on an average, temperature decreases. Okay, lower latitudinal regions experience very high rainfall, high temperature, whereas higher latitudinal regions experience very low temperature. Okay, and that too, most of the cases it is snowfall only. Okay, right. Now when it comes to India, Tropic of Cancer passes through more or less the central part of India. It divides India into two parts. Okay, the southern part of India, or the part of India which is lying to the south of Tropic of Cancer, it is near to the equator. Okay, as a result, it experiences typical tropical climate. So you have a scope for high temperature and high rainfall in southern part of India. When it comes to northern part of India, relatively it is far away from equator. As a result, it experiences subtropical or a kind of temperate climate. Subtropical, a kind of temperate climate. Okay, so in the lower latitudinal regions, generally the distinction, otherwise among the seasons, for example, when you take summer season, okay, you cannot find a drastic difference in terms of weather conditions. But when it comes to North India especially, In summer season, it experiences, North Indian cities, they experience very high temperature. And in winter seasons, they experience very low temperatures. For example, you can take New Delhi and you can take Hyderabad. In Hyderabad, whether it is in summer or whether it is in winter, you cannot expect extreme temperatures, whether high temperatures or low temperatures. But in Delhi, that is the different aspect, wherein summer, unbearable temperature, very high temperature, winter, again very low temperature. This is all because of this kind of location relief. And apart from this, you have another factor called distance from the sea. That is also responsible here. I'll come to that in a while. Next, you have Himalayan mountain system. Yes, Himalayan mountain system, they block the cold Siberian winds or cold winds coming from the Central Asian part from coming over to India. Okay, because of their elevation, they are able to block them from entering into India. First point. Second point, they will be able to block the monsoons from crossing over India. As a result, whatever the amount of moisture that is carried by the monsoons, okay, that is spent in terms of rainfall within India itself. So because of that, you have, as they are able to block the cold winds coming from Siberian region, India had been saved. It has been saved from becoming a cold desert. Okay. Next, you have the distribution of land and water. Always remember, water will have a moderating impact on climate. We have already discussed this. Water will have a moderating impact on climate, which means that it will never allow the temperature to rise up drastically or to fall down drastically. Okay. For example, when you take India, the southern part of India or peninsular India is very near to Indian Ocean region. You have Arabian Sea, Bay of Bengal. Okay. And northern part of India, relatively, it is far away from the water or Indian Ocean. That is why the southern part of India experiences moderate climatic conditions when compared to its northern counterpart. Okay, so the distance from the sea is again determining the degree of temperatures in any season. Next, altitude, obviously. From the ground with increasing height, temperature decreases. We call it as normal lapse rate. Okay, as we are moving away from the earth's surface, in the sense we are moving away from the source of temperature. So that is why temperature will come down with increasing height or elevation. So mountain tops are generally known for very low temperatures. Because of that, you have the glaciers being present on the top of the mountains. Okay. Next, you have a relief. For example, if this is a hill and winds are coming like this from this direction, these are the winds which are carrying the moisture. When they confront this slope, these winds, they try to move upwards along the slope of this mountain. Because of that, I told you that with increasing height, temperature decreases, which means that condensation takes place. Condensation is nothing but cloud formation. So, because of the upward movement of moisture-laden winds along this slope, you have the formation of clouds, and subsequent action could be rainfall. The side of hill which is experiencing the rainfall because of the upward movement of the moisture-laden winds, it is nothing but windward side of the mountain. And the other side is considered as or called as leeward side, wherein these winds gradually come down, which means that temperature increases as elevation or height is getting reduced. So that is why leeward side is devoid of significant amount of rainfall, whereas windward side is known for very good amount of rainfall. Western Ghats, perfect example, you can take the Western Ghats. Okay, Western Ghats, the windward side of Western Ghats receive very high rainfall because of the monsoons. So that is why you have the dense natural vegetation being found in this locality. And along the leeward side, it would be quite lesser amount of temperature, sorry, rainfall. Next, factors related to air and air pressure and wind. First of all, you have surface pressure and wind. I was talking about this. In Central Asia, you have very cold temperature, very low temperature, and from there some kind of strong winds, cold winds, they start moving towards India, and these winds will have their own impact on Indian climatic conditions. Okay. Next, you have the jet streams and upper air circulation. Jet streams I have clearly explained in the previous sessions. Okay. Jet streams are nothing but they are created due to the rotation of the earth from west to east. Jet streams are created due to the rotation of the earth from west to east. So that is why they are considered as westerlies. Okay. And these are upper tropospheric high speed geostationary westerlies. I repeat, jet streams are upper tropospheric high speed geostationary westerlies. They are upper tropospheric. Why? Because they blow from west to east in the upper part of troposphere, and they blow with a high velocity or speed, and they are geostationary. Throughout the year you can find them surrounding the earth, and that too they are westerlies. Why? Because they are moving from west to east because of the rotation of the earth from west to east. This is the description of jet streams. In jet streams you have two bands: subtropical jet streams, polar jet streams. This is subtropical jet stream in northern hemisphere, one belt, and in southern hemisphere another belt or band, subtropical jet stream. And you have polar jet stream at the polar region. Okay. Especially the subtropical jet stream of northern hemisphere displays crucial role as far as Indian monsoonal rainfall or Indian climatic conditions are considered or concerned. Why? Because after all, India is located in the northern hemisphere. Okay. Now, you have Tibetan Plateau region. This is India. Here you have Tibetan Plateau region. The subtropical jet stream of northern hemisphere, while blowing over the India, it gets bifurcated with one branch of the subtropical jet stream moving to the north of Tibetan Plateau region and the other branch moving to the south of Tibetan Plateau region. At this point of time, it favors or it provides favorable conditions for the entry of monsoons into India. Why? Because of this bifurcation, what happens? The combined strength of this subtropical jet stream gets weakened. Okay, and these individual branches, they were not able to block the movement of monsoons. Okay, because of that, the entry of monsoons becomes very inevitable and it will become very strong. Okay. Next, western cyclonic disturbances and tropical cyclones. Look at this map. Here you have Mediterranean Sea region, and here you have Caspian Sea region, and here you have Black Sea region. Now, in the Mediterranean Sea region, you have moisture-laden winds. Okay, and these moisture-laden winds are dragged towards northwestern part of India under the impact of subtropical jet stream. Subtropical jet stream, it blows like this, and moisture-laden winds from over Mediterranean Sea region, they are being dragged towards northwestern part of India, okay, under the impact of subtropical jet stream of northern hemisphere. So already there are moisture-laden winds. Again, while passing over this Black Sea region and Caspian Sea region, again they pick up some moisture. And when they confront the northwestern part of India, where you have Himalayan mountain system, these moisture-laden winds yield rainfall, orographic rainfall. Okay, so because of this jet streams, the northwestern part of India is experiencing rainfall. Okay, and these winds which are being dragged towards northwestern part of India are called western disturbances. Western disturbances or the moisture laden winds coming from over Mediterranean Sea region towards the northwestern part of India, yielding rainfall in states like Punjab, Haryana, okay, parts of Jammu and Kashmir, even Delhi, okay. And this happens during winter season. So in winter season, northwestern part of India experiences rainfall because of this western disturbances. This is happening because of the jet streams. Okay, right. Next, you have tropical cyclones. India experiences cyclones. Okay, and that too being a tropical country, obviously we experience tropical cyclones. And you have Arabian Sea and Bay of Bengal. Between the both, Bay of Bengal region experiences frequent cyclones or more number of cyclones when compared to Arabian Sea region. Why? Because first reason is the size of Bay of Bengal is relatively smaller when compared to Arabian Sea region. Okay, as size is small, it gets heated up quickly. When you have the high temperature, low pressure is formed. If low pressure is formed, a cyclone is nothing but, after all, it is a low pressure center surrounded by high pressure from all the areas. So the smaller size of Bay of Bengal is responsible for more cyclonogenesis in Bay of Bengal. Apart from that, second reason is this Bay of Bengal region, it lies in the path of northeast monsoons. Northeast monsoons, while passing over Bay of Bengal, they drag these cyclones towards east coast of India. Okay, as a result, east coast of India experiences rainfall. Okay, during this northeast monsoonal season, especially October till November season. Okay, for India, as far as India is concerned, this time period is considered as northeast monsoonal season. Okay, so because of the two factors, one is smaller size of Bay of Bengal, and second one is as it lies in the path of northeastern monsoons. Okay, it experiences more cyclones. Okay, so in other words, we can say that the east coast of India experiences more cyclonic rainfall when compared to west coast of India. Okay, or on average, if you have 5 cyclones in total, 4 cyclones would be originated in Bay of Bengal only. Okay. Next, mechanism of weather in summer season. Okay, you have a concept of ITCZ. This is important. For example, I have already explained while discussing the pressure belts concept. The trade winds coming from both the hemispheres converge at ITCZ. ITCZ is nothing but intertropical convergence zone, wherein trade winds coming from both the hemisphere converge with each other. The point is, this ITCZ, it shifts its position according to the movement of the sun. Okay, for example, if sun is near to the northern hemisphere, which means that is summer season in northern hemisphere. At that point of time, ITCZ shifts slightly to the north of its regular position. When sun is near to the southern hemisphere, which means that summer season in southern hemisphere, at that point of time, ITCZ shifts slightly to the south of its regular position. So because of its shifting or change in the position, you have the scope for the advent of monsoons into India. For example, here these are the southeast winds. Okay, when this ITCZ is shifting to the north, for example, if this is the position of ITCZ, okay, these southeastern winds are entering into northern hemisphere. When they enter into northern hemisphere after crossing equator, under the impact of Coriolis force, they get deflected to the right. Okay, as a result, the southeastern winds will become southwestern winds. Okay, and nothing but we call them as southwest monsoons. They move towards India, yielding rainfall there. Okay, so Coriolis force, what is meant by Coriolis force? It's a deflective force created due to the rotation of the earth from west to east. Okay, it deflects the winds to the right in northern hemisphere and to the left in southern hemisphere. Next, the intensity of Coriolis force increases away from the equator towards the poles. Okay, at the poles, the intensity of Coriolis force would be greater. Okay, these facts already I have explained to you. So this is to be the ITCZ concept, okay. Jet streams concept, I have explained it clearly. Yes, whatever the discussion we had so far, it's all about this box. During summer season, ITCZ is shifting towards the north, okay, and as a result, it becomes southwest monsoon. And during winter season, it is moving southwards. As a result, you have northeast monsoons, okay. Next, easterly jet stream and tropical cyclones. Tropical cyclones I have already explained, okay. Easterly jet stream is nothing but if this is India and this is Tibetan Plateau region, okay. From over Tibetan Plateau region towards Indian Ocean, in the upper part of atmosphere, you have the scope for the formation of some kind of jet stream called tropical easterly jet stream. Tropical easterly jet stream, which flows from over Tibetan Plateau region towards Indian Ocean region. It is not on the ground, it is in the upper part of troposphere, nothing but upper tropospheric part, okay. So this is called as tropical easterly jet stream, simply called easterly jet stream. It is temporary in nature, it is not a permanent one. It is temporary jet stream, okay. Next, the nature of Indian monsoons. You have the onset of monsoons, rain-bearing systems, and break in the monsoons. Onset of monsoons, nothing but it is the entry of southwest monsoons into India. Break in the monsoon is nothing but, for example, June to September. This is the season, southwest monsoon season in India. Okay, 4 months. In these 4 months, India experiences rainfall. It doesn't mean that every day would be experiencing rainfall. Okay, some days rainfall, for example, 3 to 4 days continuous rainfall. Then after that, you will have some kind of gap. Then after that, again rainfall. Again some kind of gap. So whatever the gap that is there in between two adjacent falls, it is nothing but monsoonal break. Okay, nothing but we call it as dry spell. Next, you have rain bearing systems. It is tropical cyclones, for example. Okay. Next, you have a concept of El Nino. This is a very, very important one. You just look at this map. So when you take the west coast of South America, this region, where you have cold Peruvian current, cold Peruvian current, cold in the sense low temperature. So what happens for every 3 to 7 years, due to the weakening of trade winds, this cold Peruvian current is replaced by warm waters. Regular cold Peruvian current is being replaced by warm waters. This is happening because of trade winds. Okay, why? Because these trade winds, they act as offshore winds. They are moving away from the shore of South America. So when wind is moving away from the shore of some continent or region, it will drag the waters from the coast of this area to the other side. Okay, so when the upper warm water is being dragged, in order to fulfill that vacuum, cold water will be coming upwards. It is nothing but we call it as upwelling of cold water from the below. Okay, but when the strength of these winds is coming down, automatically what will happen? Their capacity to drag the warm waters away from the coast will come down. As a result, the necessity of cold water coming or upwelling or coming upwards, it would be ignored. It is not required actually. Why? Because vacuum is not being formed here. Okay, so because of the weakening of trade winds here, you have the cold Peruvian current being replaced by warm waters. The El Nino means replacement of regular cold Peruvian current with warm waters for every 3 to 7 years. It is called as El Nino. It generally starts in the month of December. Okay, that is what literal term meaning of El Nino is the child of Christ, as it starts in the month of December. December month is known for Christmas season. Okay, so this is El Nino. El Nino will have its impact, negative impact, positive impact in different parts of the world. For example, when it comes to India, it would be negative impact. Okay, so rainfall, amount of rainfall being received by India would be coming down whenever you have El Nino kind of situation. Okay, why? When you have some atmospheric changes or pressure related changes in the Pacific Ocean region, somewhere in the western part of South America, how it could be able to affect the pressure conditions in Indian Ocean region? Yes, it would be affected. Why? Because you just observe this. This is South American coast, this is Australian coast, and here you have, for suppose, Indian Ocean region. Okay, so here you have one pressure center, here you have another pressure center. High pressure to low pressure, winds are moving like this, and here you have low pressure. From over, when you take the South American part, this is on the ground, high pressure, and when you take the upper part, it would be low pressure. And in the Australian region, at the ground, it would be low pressure. Above the ground, it would be high pressure. And when you take Indian Ocean, consider Indian Ocean region, in the upper part, again, you have the movement of wind from high pressure to low pressure like this, and this would be descending in Indian Ocean region. As a result, you have high pressure here. And from here, again, winds will be moving towards Australia, where you have low pressure. So in this manner, the pressure center here is determining the pressure center here. In fact, it is able to determine the strength of this pressure center. Okay, so when El Nino is happening, which means that high pressure is being replaced by low pressure. When it becomes low pressure, automatically in Indian Ocean region, relatively it would be low pressure. When you have the reduction in the strength of pressure center, automatically the strength of winds that are being pushed towards India because of this pressure center will come down. When the strength of monsoons is coming down, automatically amount of rainfall that is being or that ought to be taken place in India would be minimized. Okay, so in this manner, El Nino will have its negative impact. Next, La Nina. La Nina is nothing but, again, due to the strengthening of trade winds, weakening of trade winds, it is to do with the El Nino. Due to the strengthening of trade winds, the warm, regular cold Peruvian current, okay, whatever the temperature that is there, okay, so whenever you have the strengthening of trade winds, their capacity to drag the warm waters would be increased. As a result, more amount of vacuum would be formed. In order to fulfill that, more amount of cold water will be coming upwards. As a result, compared to the regular low temperature, you have the scope for the formation of very low temperature. When you have the very low temperature, high pressure would be very high pressure. Okay, as a result, the strength of the high pressure that is located in the Indian Ocean region would be increased. As a result, amount of rainfall received in India would be increased. So the weakening of trade winds, strengthening of trade winds is responsible for the replacement of warm waters again with the cold waters. Okay, that is nothing but La Nina. So La Nina will have a positive impact on Indian monsoonal rainfall, whereas El Nino will have a negative impact on Indian monsoonal rainfall. Okay. Next. Yes, El Nino literally means the child Christ or the Christ of child. Okay, I have explained very in detail. You just go through that. Next, break in monsoon. I told you that you have the rainfall, but in between you have some kind of dry spell. The dry spell is nothing but break in monsoon. Now, Indian climate has been divided into 4 seasons. Okay, Indian climate has been categorized into 4 seasons. First, you have cold weather season, nothing but winter season. Next, hot weather season, nothing but summer season. Next, southwest monsoonal season. Next, northeast monsoonal season or retreating monsoonal season. Okay, so these are the 4 seasons. First, we'll start with the winter season, that is nothing but cold weather season. Now, when you take India, I told you that one is the far away location from equator comparatively. Second one is distance from the sea. Because of these 2 factors, the northern part of India experiences extreme temperatures, whether it is in summer or winter. So during winter, North India experiences very low temperatures. Okay, And there are three major reasons for this, apart from this distance from the sea factor and the latitudinal factor. One is Himalayan region, it experiences snowfall. Why? Because it is a high-raised region, okay? As a result, because of the increased altitude, okay, you have the scope for snowfall, okay? This is another factor which is promoting the low temperatures in North India, apart from the distance from the sea, okay? Next, western disturbances. I was talking about this. Western disturbances are nothing but what? They are the moisture-laden winds being dragged towards northwestern part of India from over Mediterranean Sea region under the impact of subtropical jet stream. Okay, so because of these three factors, the North India experiences excessively low temperatures or cold conditions. And peninsular part of India, you cannot find a well-defined cold weather season in peninsular part of India as it is very near to the sea. Next. Generally, I was talking about this fact. From June to September, India experiences about 70 to 80% of its total rainfall because of southwest monsoons. Okay, and during winter season also, some areas of the country or some regions of the country experience rainfall. First one is northwestern part, for example, Punjab, Haryana, Delhi, western Uttar Pradesh. Why? Because of the western disturbances. Okay, and apart from that, central part of India and northern part of southern peninsula, they also receive some amount of rainfall. Next, Arunachal Pradesh and Assam region, and east coast of India. This is because of northeast monsoons. Okay, so all these regions experience rainfall during winter season. Next, you have summer season, nothing but hot weather season. Again, North India experiences excessively high temperature because of its continental interiority. Okay, and peninsular India experiences some kind of moderating temperatures because of its nearness to the water or sea. This term is very popular. Loos. Loos are nothing but hot and dry winds which are generally present during summer season in North India, especially northwestern India. Loos are hot and dry winds, okay? During the summer season, the North India or northwestern part of India experiences this winds. Other significant characteristic of summer season in India is, for example, during daytime what happens? Temperature is very high because of the direct incidence of sun's rays. When you have the high temperature, pressure would be low, which means wind becomes very light. As a result, convection of the winds takes place. Convection is nothing but what? Vertically upward movement. When you have the convection, that promotes the formation of clouds. If you have the cloud formation, obviously you can expect rainfall. Okay, so during summer, because of excessive temperature and subsequent localized convection, you have the scope for the occurrence of rainfall. These are called pre-monsoonal showers. Pre-monsoonal showers are nothing but it is the rainfall experienced in India during summer season because of localized convection. Okay, these pre-monsoonal showers are called mango showers in Kerala, Karnataka, and even parts of Telangana and Tamil Nadu, sorry, Andhra Pradesh. Why? Because they promote the early ripening of mangoes. Because of these pre-monsoonal showers, you have the scope for the early ripening of mangoes. That is why they are called mango showers. They are called blossom showers or cherry blossoms. Blossom showers or cherry blossoms in Kerala and Karnataka, especially Karnataka. Why? Because they promote the coffee cultivation. Okay. Next, they are called nor'westers or kalbaisakis in Bengal region. Okay, and they bring destruction in Bengal region. Next, in Assam, they are called Bardoli Chira. Next, loos, I have explained, they are hot and dry winds. Okay, this is a very important data from the prelims point of view. Next, southwest monsoonal season or advancing monsoonal season. When you take India, as they are moving from Indian Ocean region. First, the west coast of India, especially Kerala, Karnataka, Goa, and Maharashtra, they experience the onset of these monsoons for the first time in the first week of June. Okay, and by the second week of June or the third week, more or less, they will be able to cover entire India. Okay, these southwest monsoons are categorized into two branches. One is Arabian branch, and the next one is Bay of Bengal branch. Okay, Arabian branch is nothing but one branch moves like this. This is called Arabian branch. Next, Bay of Bengal branch, it is entering into interiors of India, and later it is entering into Bay of Bengal. And in Bay of Bengal, again it picks up the moisture. It will be moving towards northeastern part of India, where it will be able to yield the rainfall. But Himalayas, as discussed earlier, they will be able to block these winds from crossing over India. And in Myanmar region, to the east, you have Arakan Yoma and Peguyoma mountains. Okay, Arakan Yoma and Peguyoma mountains are there in the Myanmar region. They will be able to block these winds. As a result, they could not go eastwards. So unable to go back from three sides, more or less, these winds are blocked. They will be deflected towards the northwestern or western part of India. Okay, so in this manner, entire country will be covered by this both the branches, Arabian branch and Bay of Bengal branch. Okay. Next, within this Arabian branch, you have three divisions. One division hitting the Western Ghats region, other one is more or less moving hitting the Maharashtra region, and the third one entering into Rajasthan, moving along the Aravallis. Okay, but the position of Aravallis, generally, typically speaking, if you have the Western Ghats here, as a result, you have the orographic rainfall being taking place. But here you have Aravallis, but still rainfall is minimal. Why? Because I have already highlighted this fact, I think so. Orographic rainfall is possible when you have the transverse position between winds and the mountain. If mountain is able to offer transverse position, nothing but perpendicular angle, then only you can expect rainfall. For suppose if mountain is located like this, if moisture laden winds are moving like this, nothing but this mountain is more or less parallel to these winds. In this case, you have the very least possibility for the occurrence of rainfall. Aravallis, they offer parallel position to this Arabian branch of southwest monsoons. As a result, you have the less amount of rainfall being taking place there. Okay. Next, you have northeast monsoonal season. I told you that June to September it would be southwest monsoons, and later winter season starts. As a result, temperature reversal and pressure reversal takes place. So withdrawal of these monsoons takes place. This withdrawing monsoons, also called retreating monsoons or simply northeast monsoons. Why? Because this is their direction. Okay, so winds are generally named after the direction from which they blow. Okay, these northeastern monsoons, more or less, they yield rainfall along the west coast of India only, especially Tamil Nadu, parts of AP and parts of Odisha. Okay, the western part of India or other parts of India, they do not experience much rainfall because of these northeast monsoons. Okay, and these northeast monsoons, they pick up the moisture while passing over Bay of Bengal. Okay, and this is the season for the formation of cyclones. So when you have the formation of cyclones, they will be dragged towards eastern part of India under the impact of this northeast monsoons. So that is why cyclonic rainfall, eastern coast of India is prone to more cyclonic rainfall when compared to west coast. Okay. This Tamil Nadu region, more or less, it experiences less amount of rainfall due to southwest monsoons, as it is more or less running parallel to the Bay of Bengal branch, and it is lying in the rain shadow region of Arabian Sea branch. Okay. And during the northeastern monsoonal season, you have another concept called October heat. Okay. In the month of October, generally, we experience very high temperature and humid climatic conditions. Weather becomes very hot and humid in the month of October because of this retreat of monsoons, nothing but northeastern monsoons. This is called October heat. And you have some traditional Indian seasons. Okay, you just go through that. Nothing much significant from the examination point of view. Now, the distribution of rainfall in India. You have areas of high rainfall, areas of medium rainfall, low rainfall, inadequate rainfall. Okay, areas of high rainfall, for example, if this is India, obviously the Western Ghats region, especially Kerala, parts of Karnataka, and next Meghalaya region. Okay, they experience relatively very high rainfall. Next, areas of medium rainfall, you have Gujarat, Tamil Nadu, northeastern peninsula covering Odisha, Jharkhand, Bihar, Madhya Pradesh, northern Ganga plains. Okay. Next, Manipur region. Next, areas of low rainfall, Punjab, western UP, Delhi, Punjab, Haryana, Jammu and Kashmir, eastern Rajasthan, Gujarat and Deccan Plateau region. And areas of inadequate rainfall, obviously, the western part of Rajasthan and parts of Andhra Pradesh, Karnataka, Maharashtra, Ladakh region, etc. Okay. Next, you have the variability of rainfall. Okay, variability. Try to remember. Variability of rainfall is more in the regions which experience less amount of rainfall or which records less amount of rainfall. For example, you have northwestern part of India, especially the western part of Rajasthan. The western part of Rajasthan experiences very low rainfall. Then you can say that variability of rainfall would be more in western part of Rajasthan as the rainfall is very less. For example, you have the Western Ghats region, nothing but Kerala or Meghalaya region, where you have high rainfall, which means that variability would be lesser. Okay, try to remember like this enough. And apart from this, you have Köppen's climatic classification. He has provided for some type of climates. Okay, I will do one special session on this Köppen's climatic classification. Why? Because the data is not that much adequate that is given in whatever the data that is given in NCERT. Okay, so adding some more data, I will be discussing this Köppen's climatic classification in some other session. Okay. Next, monsoons and economic life in India. Yes, majority of the people in India, they are dependent upon agriculture only. Ours is an agrarian economy. When it comes to the dependency, most of the people, they are being dependent upon agriculture only. And agriculture, it is mainly rain-fed agriculture. Scope for the irrigation is very minimal. Okay, so as majority of the people, they are dependent upon monsoons or rainfall for their water needs. So if something goes wrong with the monsoons, automatically that is going to affect the people who are dependent upon agriculture. Okay, that is why you have a popular phrase like Indian economy is a gamble, or Indian agriculture is a gamble of monsoons. If something goes wrong, monsoons, automatically that is going to affect agriculture, which is going to affect economy. Okay, this is with your climate chapter of NCERT. Okay, thank you.